Ever try to hold on to like a handful of air? It just kind of slips right through your fingers, doesn't it?
It really does.
Well, today we're diving into something even more elusive. Something that's been frustrating, like scientists and engineers, really since the 1700s. Hydrogen. You sent us some seriously fascinating research about the immense challenges of actually using this gas as an energy source. And let me tell you, it's a real wild card, this hydrogen.
Oh.
Full of surprises and not always the easiest to tame.
Yeah, that's right. Even those pioneers of chemistry like Cavendish and Lavoisier, who were some of the first to really wrap their heads around hydrogen, even they struggled to contain it.
Yeah.
Imagine just being brilliant enough to discover an element, but then it just keeps escaping through your test tubes. It's like, how do you even...
It's got to be deflating.
It's like trying to hold on to a cloud.
Right. Like, I bet that was enough to make even the smartest folks,
Oh, absolutely.
scratch their heads a little bit and think, what are we dealing with here?
Mhm.
And these documents you sent, they explain that it all comes down to its size or lack thereof. Hydrogen, my friends, is the tiniest molecule on the entire periodic table.
It's true.
It's so small, it can slip through spaces that we usually consider,
Airtight.
they're right, exactly.
And that's where the real fun begins, because this tiny molecule has a huge impact on how we handle and store it. Just look at those early attempts to use hydrogen in things like submarines back in the 1940s.
Oh, wow.
The problem wasn't always so much the explosions as it was the permeation.
Okay, permeation. That's a fancy way of saying
Yeah.
hydrogen escapes, right?
Think of it as a superpower. Hydrogen can literally seep through materials, even metals, because it's like they have microscopic holes as far as hydrogen is concerned.
Wow.
It's a huge design headache,
Yeah.
one that still plagues engineers today.
So it's not just about keeping hydrogen contained. It's about finding materials that can actually, withstand its Houdiniac. Which makes me think about those exploding balloons from science fairs.
Right.
They suddenly seem a lot less like a fun experiment and more like a cautionary tale when you start thinking about it on this scale.
Yeah.
Speaking of tales, we can't talk about hydrogen's escape artistry without mentioning the Hindenburg.
Oh, yeah. A tragic event, to be sure.
Yeah.
And while the exact cause is still, debated to this day, hydrogen leakage was very likely a contributing factor to what happened.
For sure.
It really drove home the point that hydrogen needs to be handled with extreme care.
Yeah. And definitely not the kind of publicity hydrogen needed if it wants to win over the public. You know what I mean?
Right.
But these documents also show that we have made a lot of progress since then. I mean, NASA has been using liquid hydrogen for rocket fuel for decades.
That's true, but it took a lot of innovation to get there.
Not bad.
We're talking super insulative tanks, specialized alloys, and all sorts of ingenious tricks to keep this slippery gas in check.
Wow.
And the research continues. They're constantly developing even better materials.
Wow.
PTFE, composites, even nanomaterials.
Wow.
It's like an ongoing game of one-upmanship with hydrogen, finding ways to outsmart its tiny size and its restless nature.
So we're making progress, but it's clear that the challenge of containment is far from over. But even if we manage to hold on to this gas, the story doesn't end there. It's not enough to just keep it from escaping. We need to use it effectively, right?
Right.
And that's where things get really interesting. You keep mentioning the hydrogen economy, and honestly, it does sound pretty futuristic. But these findings make it clear that it's about more than just holding on to hydrogen. Like, we need to figure out how to actually use it safely and effectively, which seems to be, well, easier said than done, right?
Oh, absolutely. Hydrogen has a real knack for throwing curveballs our way, even when we think we've got it figured out.
Yeah.
Take the Joule-Thomson effect, for example. It's a real head-scratcher.
Now, that's a term I bet a lot of our listeners haven't encountered before. Could you break it down for us? What is this Joule-Thomson effect?
Sure. You're familiar with how most things cool down when they expand rapidly, right?
Yeah. Like, think about how deodorant feels cold when you spray it.
Exactly. That's the Joule-Thomson effect in action.
Oh, okay.
Yeah.
Right. Feels like magic, but
Yeah.
I'm sure there's, a perfectly logical explanation for it.
Exactly. Most substances lose heat as they spread out, basic physics. But hydrogen, above a certain temperature, decides to play by its own rules, and it actually heats up when it expands. Imagine trying to design, like, a cooling system, only to find that your hydrogen is actually turning up the heat instead. It's this kind of quirky behavior that makes hydrogen both fascinating and a bit of a challenge to work with, to say the least.
So early attempts to, cool hydrogen down must just completely backfire. It's almost like trying to put out a fire with gasoline.
Yeah, that's a good way to put it. It wasn't until the late 1800s that a clever scientist named James Dewar finally figured out how to tame this wild gas. He discovered that if you cool hydrogen below its inversion temperature, which is kind of like its freezing point for this weird heating behavior, and then expand it, you can finally get liquid hydrogen. It was a huge breakthrough.
Talk about a scientific plot twist.
Right.
But as if explosions and sneaky leaks weren't enough, there's another issue this research kept highlighting, and that is hydrogen embrittlement. It sounds like something straight out of a science fiction novel.
It's not that far off, actually. Imagine a perfectly sturdy metal bridge or a pipeline, even a spaceship component. Now picture this. Exposure to hydrogen can make these incredibly strong metals as brittle as like a dry cracker. Not exactly what you want in a critical piece of infrastructure, is it?
Definitely not. What causes this metal munching phenomenon? Like, does hydrogen just eat away at the metal like some kind of microscopic gremlin? Or what?
Well, it's not quite that dramatic, but you're on the right track with the microscopic part. Hydrogen atoms are so small that they can actually infiltrate the spaces between the atoms of a metal. It's like, imagine tiny termites weakening the structure from the inside out. This can happen in a few different ways. Sometimes the hydrogen messes with how the metal atoms are bonded together. Other times it actually creates these tiny little pressure pockets that weaken the material. Either way, the result is the same. The metal loses its strength and becomes prone to cracking.
So it's not just about hydrogen escaping. It can actually sabotage the very things we're using to contain it. Talk about adding insult to injury. Are there any, industries that are especially vulnerable to this?
Oh, absolutely. The oil and gas industry, for one, has been grappling with hydrogen embrittlement for decades. Think about, pipelines transporting hydrogen-rich fuels, storage tanks under high pressure, they're all susceptible. And as we move towards a hydrogen-powered future, this problem is only going to become more widespread. Imagine the implications for hydrogen-powered vehicles, fuel cells, the whole shebang.
That is a sobering thought. But surely scientists are working on ways to fight back against this, this metallic mayhem, right?
They are. Material science is a really exciting area of research right now. Scientists are developing new types of steel that are more resistant to hydrogen embrittlement. There are also protective coatings, like special paints, that can act as a barrier. And then there's nanotechnology, which is like the cool kid on the block these days. Imagine manipulating materials at the atomic level to essentially trick hydrogen into thinking there's no metal to infiltrate in the first place.
So there's hope for, durable hydrogen tech yet. That's good news, because this next batch of research you sent seems to throw even more challenges into the mix. It looks like we need to talk about how we even get this much hydrogen in the first place, because simply capturing it from the environment doesn't seem to be an option. So we've talked about the challenges of storing hydrogen, transporting it, and even the risk of it, like making our infrastructure as crumbly as a cookie. But this research you sent, it also dives into something we haven't really touched on yet, and that is, how do we actually get this much hydrogen in the first place? I mean, I can't imagine we're just plucking it out of thin air, are we?
You're right. It's not quite as simple as scooping it up. And this is where things get a little tricky, because even if we solve all those storage and material challenges, we still have to address one of the biggest elephants in the room, which is producing hydrogen in a way that's both clean and affordable.
That makes sense. I'm seeing articles popping up all the time about green hydrogen. What's the deal with that? Is there a non-green kind of hydrogen lurking around that we should be aware of?
You've hit the nail on the head. The most common way to produce hydrogen right now is through a process called steam methane reforming, or SMR for short. Sounds pretty straightforward, right?
Yeah.
Basically, you mix methane, which is natural gas, with superheated steam, and out pops hydrogen.
That sounds almost too easy.
Yeah,
There's got to be a catch, right?
There's always a catch. While SMR is efficient, it still relies on those fossil fuels, and it releases carbon dioxide as a byproduct.
Huh, okay.
Not exactly the clean energy solution we're all hoping for.
Right.
That's where the whole green hydrogen thing comes in.
Yeah.
It's made by splitting water molecules using renewable energy sources like wind or solar power.
Okay, so green hydrogen, that sounds like the way to go.
Yeah.
What's the holdup? If it's so great, why isn't everybody doing it?
It mostly comes down to cost and infrastructure. Right now, green hydrogen is still significantly more expensive to produce than hydrogen from, say, natural gas. Plus, we'd need a massive increase in renewable energy generation and infrastructure to really support widespread green hydrogen production. It's a classic chicken and egg problem.
It seems like every solution we uncover with this hydrogen just leads to a whole new set of challenges. But, okay, let's imagine for a second that we do get there. That green hydrogen becomes like as commonplace as gasoline is today. This research you said, it also dives into some safety concerns. Are we talking Hindenburg 2.0 if we're not careful with this stuff?
Not necessarily, but hydrogen does have some unique properties that definitely require extra attention. For one thing, it's flammable over a much wider range of concentrations in air compared to something like natural gas. And it takes a surprisingly tiny spark to ignite it. We're talking like static electricity levels of tiny.
Okay, so maybe no hydrogen-powered birthday candles anytime soon then, huh? What about those hydrogen sensors I keep hearing about? Are those just for peace of mind, or are those absolutely essential?
They're absolutely essential. Unlike natural gas, which is often given a distinctive smell to help detect leaks, hydrogen is completely odorless.
Oh, wow.
Those sensors are basically our early warning system because hydrogen flames can be nearly invisible, especially in daylight.
Invisible flames. So that's just not playing fair. Anything else we should be keeping in mind as we venture further into this hydrogen-powered future?
Well, the environmental impact of hydrogen isn't as simple as, just zero emissions either. There's still a lot of debate about its potential effects on the atmosphere, especially if it leaks before being used. Remember how easily it escapes? Some scientists are concerned that it could react with other gases and potentially even impact the ozone layer.
It seems like hydrogen just has this knack for keeping us on our toes. Definitely not a simple good guy or bad guy in the clean energy story.
Exactly. It's a very complex picture with both potential benefits and risks that we need to very carefully consider. Hydrogen has a lot of potential, but it's not a silver bullet.
That seems to be the recurring theme with this hydrogen, doesn't it? So much promise, but with, some serious caveats to address. Which kind of makes me wonder, will we ever truly see a world powered by hydrogen?
It's a question worth pondering, that's for sure. There have been so many promising projects over the years that haven't quite lived up to the hype. Remember that whole hydrogen car craze not too long ago?
Oh, yeah. It seemed like every car company was jumping on that bandwagon for a minute there. Whatever happened to that?
Yeah, it largely fizzled out, mostly due to the challenges we've been talking about. The cost, the infrastructure, and even just public perception at the time.
So what's different now? Is this just another one of those cycles of hype that will eventually fade away? Or is there something more to it this time around?
It's a fair question. But there are some reasons to be cautiously optimistic this time, I think. The urgency of climate change is basically impossible to ignore at this point.
Right.
And governments and businesses, they're finally starting to invest, serious resources into cleaner energy solutions.
True. Feels like everyone is starting to feel that pressure now.
Yeah.
And not just, environmental activists.
Exactly. And hydrogen, despite all of its challenges, it still holds just enormous potential, especially if we can find ways to overcome those production hurdles and produce it sustainably at scale. Plus, the technology has continued to advance even during those periods when the hype died down.
So while history might make us a bit skeptical, there's a sense that this time things could be different. The stakes are higher, the technology is more advanced, and there's a global push for change that we just haven't seen before. Will hydrogen finally live up to its promise as the clean energy solution? The challenges are significant, but the pursuit continues. And on that note, we'll leave you to ponder the possibilities. This has been The Deep Dive, signing off.